There's this old saying in our industry that bold, agile, and successful web development is all about moving fast and breaking things. And I think it captures the spirit of a time on the web when people were talking a lot about taking big risks and failing a lot, kind of as a goal, being a little reckless. Now, in fairness to the folks who coined the phrase, I don't really hear the sentiment so often anymore. So maybe, I don't know, they got tired of fixing all the things that they were breaking. So it's a phrase from kind of a more naive time in our field. But despite all that, despite the age, I borrowed it today because I find it really relatable for totally different reasons than they intended. That's because regardless of whether it's our stated goal, I think it's really easy for us to break things on the web for our users, especially when we're moving fast. And fast, in this case, refers less to performance and more to the changes that we make day to day while we're running a website. Building new features, changing what we have, addressing the priorities of a project that are always coming in. But fitting with the conference theme, many of those fast moves that we're making also tend to threaten our ability to move fast from a performance perspective, too. So today I want to share a few things. Some are technical, some are not so much, that I find really helpful when trying to make our websites fast, and also more importantly, keeping them that way, which I find is kind of harder than the first part. So let's talk about moving fast and not breaking things. The web is a really tricky medium to work with. Tim said it a lot, but there are so many factors that can compromise the delivery of the experiences that we build that are beyond our control, right? As a web designer, I feel like I've spent so much of my career just trying to build things, useful things in ways that don't break in the process. But interestingly, I think that our notion of what it means to break things on the web has been evolving and changed several times as well. Anyone remember this site? Position is everything. I think I'm the oldest person here. So if you've been making websites as long as I have, since the days of the browser wars, you'd probably recognize this. And you'd recall that the early versions of the browsers that we know today, in them, making a non-broken website was really difficult, but I think difficult for different reasons than it's difficult to do that today. Reasons that kind of seem a little funny in hindsight. And that's because early on, I think we had to borrow our success criteria from other media, like print and TV. And at least in the circles that I followed, this led to this sort of strong emphasis on consistency, right, and reproducing our designs and our interaction across the very few popular places that we were deploying them at the time. And those few browsers behaved differently than one another in subtle but really tricky ways. You know this website, right? Quarks mode? All right. So making a website that looked and behaved the same way across browsers that had all of these yes and no and maybe an incorrect kind of handling of all the things we were doing was difficult. And we'd spend hours poring over this site and trying to get it right. So in order to address the challenges of those days, I think many of us chose to align with one of two kind of high-level philosophies. Browser detection, so checking the UA or something similar to that, and serving a unique experience to that browser or device. Or feature detection, right? And trying to build one thing that's smartly negotiated between all of the different handlings and quirks. And the browser detection approach, I think, was pretty simple technically then, because there weren't a lot of targets we were looking at. And as much as I'd regret to admit it, it was kind of reliable most of the time. Like, we would focus on edge cases where it would fail. And it did sometimes. But the feature approach at that time, it was more sustainable, and we could tell that, but it was really nuanced and ridiculously hard to get right. So I think it really speaks to the kind of people who get into this field that given these two choices, most of us decided that without a doubt, the second approach was definitely the one we wanted to take, right? The harder way. And that approach fit into this greater kind of practice that we call progressive enhancement, which a few speakers have thankfully been covering. The idea of delivering something simple to any HTML literate device and then carefully qualifying enhancements without breaking what we've already delivered. So PE delivered and provided us, I think, adequate tools, but also kind of a tedious tool set for negotiating the quirks at that time. And looking back at that simpler kind of time in our field, it's kind of surprising to me that it took hold at all, but I'm really glad that it did, because soon it became a lot more useful to us. It seemed like overnight, with the introduction of smart mobile devices, the web changed beneath our feet. And this started an explosion of diversity in web browsing contexts, not just mobile. We always talk about, then the mobile web happened. But it went in all directions simultaneously, right? And it continues to this day. At once, devices were getting screen sizes and resolutions, both larger and smaller. Processing speed and hardware were changing in both directions as well. Touch screens made us rethink all of these patterns that we had thought through with mouse-specific behavior. And that kind of made us realize that keyboard navigation was more important all along, and touch mapped really neatly to focus-based navigation that keyboard users needed in the past. And we kind of like neglected that, so it was good. Additionally, new browsers came along, and new capabilities were arriving in inconsistent order. And some even started splitting their rendering between the device and the cloud, those proxy browsers that Tim mentioned. And our networks were changing too. LAN networks getting faster, cell networks were some of the slowest that we had dealt with in years. And this diversity continues in really weird and interesting ways today. Back home, for me in Florida, in the US, my cell connection is faster than my Wi-Fi at home. Florida's kind of a confusing place, but these kind of edge cases happen, all around us, and they continue. So by the time all these changes started happening in all directions, I think it became clear that we had been making a mistake. Trying to make a website look or behave the same way across different browsing environments was a bad idea, right? And our notion of what constituted a broken experience at the time was broken in itself. So our criteria would shift for the better at that point. So from that point on, we would sort of aim to cater to each contextual environment and its features uniquely. And I think that was pretty freeing, but also humbling. Fortunately, I think the cool part of this was, despite our criteria shifting and what it means to deliver a good experience, progressive enhancement was still there to help, right? It gave us the tools we needed to deliver on new goals, which were almost opposite the goals that we cared about just days earlier. And I find this is a recurring theme, and that's why I'm kind of going into history here. It has all these similar beneficial effects in other areas that we need to care about, areas that might otherwise break. For example, progressive enhancement and specifically responsive layout and fluid layout allowed us to qualify and target our UI designs so they could adapt, right? And without any effort on our parts, recently, that made us ready when the web just kind of landed on wristwatches. Another benefit is accessibility. When we start by delivering HTML that's meaningful, we get strong accessibility by default. So often we don't need to add accessibility later so much as retain it and sort of defend what we have so it doesn't break as we enhance it further. Also SEO, meaningful HTML. It's the staple food group of web crawlers, right? It is true, they do, like Google does, parse pages that are generated by JavaScript, but it doesn't do it as well. I read recently that JS-generated sites are actually parsed on a 1-week delay in Google because it's costly. They have to fire up browsers to actually render these sites. And it's unclear what other what other search engines do at all with it. So these are all sort of things we need to prioritize and balance when we keep performance in mind. And given all these ranging benefits, I guess I shouldn't have been surprised when I came to understand personally that progressive enhancement is also fantastic for performance. But it still surprised me, because I guess I always thought of progressive enhancement as something that paired well with performance practices, like the old ones we used to think about, like making our files smaller, optimizing images. And of course, it pairs well with all that too. But another picture of Jake. But what I mean to emphasize is that progressive enhancement itself is a performance best practice of its own. And I think by using the patterns of progressive enhancement and sort of an ethic of generally trying to get out of the way, of ourselves often. By default, that sort of makes us somewhat of a performance expert, which is terrifying. But here we are. For me, I think learning this benefit came at a really convenient time because there was another shift happening. Right around that time, a lot of the folks in the front row and all the rows, really, in this room, were starting to talk about new important metrics in performance that we had to care about. So once again, we were shifting our ideas of what was constituting a good or a broken experience on the web. And I think so many occasions come up where things can break for our users, and in particular when trends evolve in ways that threaten our performance. In these cases, our problems can be solved by correcting our workflow back to these patterns that we know were fast in the first place. And it's really awesome to see the JavaScript community latch on and really embrace that in the last couple of years. This is a quote from Netflix, which runs React, and just by using server rendering of their React, I mean, the stats are incredible. They sped up their performance. I mean, it's a shame we're adopting approaches that probably regressed that far to begin with, and we should keep an eye out for that. But server rendering is now a first-class kind of pattern. Frank Chimero has this beautiful essay called The Web's Grain. Some of you might have read it. He talks about complexity, what the web does well, and that like other physical mediums, he feels that it has a grain of sorts. And I think that's a nice sentiment. In the case of performance, I think that grain runs in the direction of page rendering in a progressive fashion, right, as all the speakers have reminded us, and becoming usable quickly without delays. So it's clear, I think, from the past couple days that we've all sort of come to recognize this, largely because our tools have gotten so much better. The way we measure performance has improved so much. So we have new metrics that we've been talking about. Let's review those. Where I work at Filament Group, most of our work is in designing and building newish websites or redesigns for clients big and small. But we also sometimes get to work on performance evaluations of existing websites. And these are pretty fun and interesting, I think, because we get to contrast those two workflows. And I'm seeing big differences in the way we think about making a site faster and keeping a site faster. So we get to look at ways to make their site fast, right? Somehow no one has mentioned this tool yet, so I'm just going to say it. It's called Webpage Test. It's really great. I actually recorded a video, in case you've never seen it. This is how it works. Put a URL in. You get to choose a browser, a network speed, 3G in this case, the number of runs you want to do, and capture video, which is great. And then when you're ready, you hit start. And the minor hang up, but this is actually super important. You have to prove you're a human to get any further. Never let the robots know how we make websites fast. Our jobs are on the line. You don't think automation's coming for you? Kidding yourself. So after that, you'll land on this results page, right? And you start to get sort of a high-level summary of what's going on. I like to scroll down just to the side of the tall waterfall and look at these timeline views, which are really neat. This is where we start to see a really visual representation that we can talk to clients about these metrics that really matter to users, right? File size matters quite a bit, as we've talked about quite a lot, but these two metrics, first, meaningful content and time to interactive, are coming up again and again and again. So let's talk about some ways to speed those up. First, a little bit about first meaningful content. This is about perceived performance of the initial rendering, right? So how soon does the page look useful? Progressive enhancement, once again, I'm like a preacher up here, but it's such a natural tool for optimizing for this metric. Right? That's because starting with meaningful HTML and sort of layering in an unobtrusive way is the best way to get to this quickly. As Natasha told us yesterday, pages often require more than one round trip to the server to start rendering a page, right? So in that race to first meaningful content, we really want to reduce those round trips. So let's do that. When the browser first gets that HTML and starts looking at it, it'll scan through for references to files that it sees, and it needs to fetch before it goes further, right? In the case like files like CSS and JavaScript, it'll often stop in its tracks, right, and go fetch them before it can evaluate them and then continue rendering again. Now, I think when the browser has HTML in its hands already and it can't start rendering, that's kind of a new way of breaking the page. At least to the user, it could be a temporary delay, but it could be really long if it's a single point of failure, right? If it's really delayed on the other end. So I think that's something we can do a lot better with. So when we start to look at this part of the page, we say, okay, I see some areas for improvement here. With the scripts, we just want to get them out of the way, right? So we can add these attributes, ideally. If we can't move them to asynchronous and defer them, then we want to just make it happen as quickly as possible, right? If it's small enough, we could inline it, get it done quickly, get it out of the way. If it's not small, then you probably just need to re-architect your entire website, because it's probably not a good approach, right? So we're seeing more and more teams move this part to the server if there is that much JavaScript dependency up front, because it's such a big blocking problem. CSS is fuzzier. That's because at least some of the CSS really does belong here, right, in the head of the page. If it's not there, then you'll get a flash of unstyled content, right, while it's still loading. We can't just async the whole style sheet. But leaving to go get it right now, I think is kind of a waste of time, because we're already there. It's like getting all the way to the restaurant and realizing you don't have your phone, so you can't take pictures of the food, or your wallet, or whatever metaphor works for you. So we want to think of ways of bringing what we need with us. One sort of experimental way is to try that with server push. We actually run this on Filament Group's site. So in the wild, it's working pretty well for us, but it's interesting. Let's talk about it. Yoav mentioned it earlier today. It's an H2 technology. It lets us decide to send assets back to the browser that it didn't even ask for yet. It's really rude. So a request for a particular page on your site might come back with additional files from the server that it knows you're going to be requesting soon. And it's pretty helpful. It can save round trips, right? The HTML receiving a push doesn't have to change at all. Like an ordinary link to a style sheet is ready to receive a push, hopefully by the time the browser looks to local caches and then the network. It'll find it in a push cache and use it, right? That's ideal. If you're running a server like Apache, setting up push is kind of dangerously simple. A line like this can go into one of those crufty old htaccess files you probably have kicking around in the attic. And this will push site.css along with every request that comes to your site, which is a terrible idea. But you would probably want to qualify it further, right? Like only push on requests to documents that have HTML in the file name. So you would start to conditionalize throughout your site, maybe only push if there's a cookie set or not a cookie set. So you only have to push if they haven't received this file before, because we don't have better technology for that yet. Even then, push is really complicated to try to deploy at scale. And on the browser support side of things, it's still a little shaky. Safari has been shown to not use a pushed file and go back to the network occasionally, but it's an open ticket with WebKit still. So there's a little shakiness there. It's good to experiment with it, I think. But you might just consider inlining instead, which probably, again, makes me sound really old. But that's okay. I think inlining is a good old school kind of approach if you use it well. And it still might be the most reasonable approach to get your important CSS to the browser in that first delivery. Unlike push, you will have to modify the HTML if you're going to inline something. probably obviously. Here's an example where the contents of a CSS file is embedded right into a style tag. Looking at this, you might immediately start to think about the drawbacks, right? It's terrible for caching. That CSS is meshed right into another file, so you can't have it in an isolated part to request later. So traditionally, we might have to load it again or something in a single file, and that's another request, but we could maybe do it in a way that doesn't block anything. But maybe you could try something a little fancier. This example shows a style block and a script below it, and we've got an ID on the style, so I can find it later with the script, and a little inline CSS there. And then the JavaScript is getting the contents of that style block, and it's using a new API called caches, which is not actually tied to service workers, but you're probably familiar with it if you've used service workers before. So it's taking the contents of that, and it's stuffing it into a new response for a file called site.css that doesn't actually exist. But if you have a service worker on your site that's designed to look to local caches first, then subsequent loads on your site that request site.css will pull it locally, right? So we're actually saving a request. And that kind of makes inlining cool again to me. I mean, you're kind of doing what push does in a way with inlining. So another downside, if the CSS is really large, you can't just inline the whole thing, right? You'd put too much unimportant code in that first response. So this is a tip from Google that you want to, this is from, PageSpeed Insights documentation at Google, that you want to identify and inline the CSS necessary for rendering above the fold content. And Katie got into this earlier. We call this critical CSS or render critical CSS. The idea has been around a while. I'm mentioning it again because the impact is so huge. It's so cool to see a site render immediately when that first, like it's almost close to time to first byte when you start to see the page start to render because everything is there in the browser. This is a visual comparison to describe what's going on with that CSS a little more. This is a page on Filament Group's site, rendered exactly as Tim Berners-Lee intended it. And over here, we have a page with just the critical CSS applied. So you can see that red line is where we cut it off, and things just start to fall apart over there. There's no CSS for those elements to give this layout. So we've only delivered the part that's relevant to the first portion of the page. In code, that would look something like this. Full CSS would be very tall over here, and then you can think of critical CSS as a sort of subset. And there are tools to do this for you. I would never recommend manually figuring out the styles that are necessary for this. One good tool is by Adi Esmani at Google. It's called Critical. We maintain one at Filament called Critical CSS. There are also Apache modules you can add that Google maintains that'll do this for you. So again, the tools will create that subset file for you, but then you can inline it, right, into your page. So I'm kind of like doing some pseudocode here, but you would include that file that was generated as the critical CSS for that page. So that gets into the head of the page. But it's only a subset, right? We just extracted that out. So you'll want to load the rest of your CSS too. Ideally, you'd want to do that asynchronously now and not block the page because you don't need it right away. It's kind of critical, especially if you start scrolling the page. You want it to be there soon. But we want to load it separately. So we want to do that with HTML, and there's nothing in HTML that gets us there declaratively, but we can use, as Yoav was showing earlier, we can use link-rel preload as a primitive for a style sheet loader. So by adding an onload handler and flipping the rel attribute to style sheet, that'll apply the CSS file to the page once it loads. And it'll do so in an asynchronous manner. So that'll work in any browser that supports preload. And in this case, we actually want it to work everywhere. So browser support is a little shaky still. You know, Internet Explorer will never have preload support. Firefox had it in 56, and then they messed a couple things up, so they pulled it. It's under a flag now. It'll come back. But we can polyfill it, and I'd recommend doing that. There are maybe a couple others, but we maintain one polyfill for this called CSS rel preload. Steve mentioned the load CSS project. This is part of that, but it's actually an independent script. And you bring it into your page, it'll just enable any preload links to CSS files that it finds. So I bring up this first section on first meaningful content optimization because it can have huge payoff. This was a case study that we did on an article page on the Wired site. And up top is their typical timing. And by just applying these optimizations to the scripts and styles that existed without changing anything about page weight, we dropped the speed significantly. So a heavy page can appear to load quickly, which is sort of a bad thing because it's enabling. But it's true, right? But that doesn't mean weight doesn't have a cost, right? These are the numbers that Tim showed earlier, so I don't need to re-explain them. I think they're just in personal experience, anecdotally, kind of light, right? Like compared to the popular sites on the web, news sites, things like that, they tend to be a lot heavier than this. Just some homepage numbers from some popular news websites. Some are right on the mark, but you know, CNN on one run I did was 6 megabytes. New York Times is pretty heavy. And then homepages tend to be a little lighter than the articles, which of course autoplay video. I mean, there's no article page on the web anymore that doesn't autoplay a video. So they're really heavy. And there's a real cost to that download weight, right? But as Steve pointed out, not all code weight is created equal. JavaScript packs a ton of damage for its weight. And in those two big metrics, weight really factors into the second one a lot, time to interactive. And that's because more and more, increasingly, it's the time that we're waiting for JavaScript to run after it's been downloaded. This is a visualization from a post by Adi Osmani again. And I think it's so good because it just like illustrates that frustration. You're probably feeling stressed out just watching this. You know, you want to use the page, and it's just, you know, it's there, but it doesn't work yet. So it's frustrating. And I think, you know, this is an interesting predicament we're in right now. Adi notes that we should be aiming for interactivity in under 5 seconds on a slow 3G connection median mobile device. That median mobile device is not the phone that we're reading about, the $1,000 new iPhone. It's more like the $100, 100 euro-ish category phone, which hasn't dropped in popularity despite all the attention on these really expensive high-end phones that are much faster at parsing JavaScript. That low-end, but actually average phone takes 2 seconds to process 1 megabyte of JavaScript. That's already downloaded, so that's after it transfers to the device. So you can add that to your initial rendering time. And keep in mind that that's uncompressed JavaScript, right? So if you're transferring a megabyte, it's going to be a lot larger when it uncompresses, decompresses on the device if you're using something like gzip. So we want to aim for under 200K-ish. Adi says 170K, just to give us a fighting chance at getting a under 5-second experience. And networks are steadily getting faster too. So this is this enabling problem, right? This is data from Ericsson's mobility report this year. LTE is really creeping up, right next to 3G in yellow. And I think that increase is kind of dangerous for developers who have these nicer phones because we're seeing things transfer really quickly and execute really quickly. So if we move that assumption to all these other devices that are still getting those fast transfer times, it's pretty dangerous because they're choking on all the things that we send. And that leads us to wonder what all that JavaScript is doing, right, and whether we need it. So first-party code tends to be a little more responsible. We have really good tools to manage it, like code splitting and Webpack. You're able to break things up and only serve what a page needs. Third-party code, as Harry reminded us, is where everything kind of gets destroyed these days. So that brings me to a sort of sobering realization recently. I think it's often easier to make a fast website than to keep it that way. And increasingly, that's because so many people on the team have access to tools that can impact the site's speed. So there are great tools that we can use to monitor the site's speed day to day and keep budgets. But I think the tools that we use may need to happen in more than one place, right? For developers, we have these great tools, and it feels so good to work in GitHub and send a pull request and like see that it passed the budget test and we're doing well. But we're often not able to see how this impacts the live site when there are scripts, third-party scripts, that aren't deployed in these staging environments that only get deployed on the live site, and there are huge regressions on that side. So in those environments, I think we need to be looking at tools like Speed Curve and Caliber, because clients get really excited about seeing those dashboard interfaces and being able to see a regression. Even if it's a little after it already happened on a live site, it's still useful, and they can make good decisions. So we do a lot of work with commerce clients, and their marketing teams use a lot of third-party tools out of convenience, right? They use them for product reviews, comments, user analytics, personalized content, A/B testing, targeted advertising, and then they have a tag manager on top of all that, which is also third-party JS. And the impact of these is not apparent in our testing environments, right? So as developers, it's not always our role to decide whether these are added or not to the project, but it is our job to make sure everyone on the team is aware of their cost. And thankfully, some of that nagging that we've been doing in our community is translating over to the tag manager community, I think. I noticed Adobe's new iteration of its tag manager called Launch has slightly softer wording about async loading in its docs than it did in its previous generation. It's not outwardly saying you can async load everything, but it's at least recognizing that there's a problem. So we should be pushing back on this. And that said, it's hard to convince a team to remove a script at all, and often we're just losing these arguments. So if we can't do anything to change that these scripts are being added to the page, at least try to preload it if it's added late in the page, because the result can be really good. This is anecdotal, but this is one site where we just preloaded some third-party scripts that were down lower in the page, and you can see the impact on rendering. It's quite significant. So let's talk about other ways to avoid damage of these integrations. Personalization and dynamic content, they're not going away. Clients love these things. They see results. They're making more money from them. Specifically, client-side A/B testing and personalization are becoming so popular not only because they work, but because they're convenient, right? They can manage them without really touching the code base. But these tools come at a huge cost, right? And that cost is usually transferred to the user. So the typical pattern goes like this, right? The HTML is delivered to the browser along with some scripts, and once they get the scripts, they start parsing them, and then they sort of wipe out the page, and there's a long delay, sometimes many seconds, and then they churn out a new view, right? So today I'd like to introduce a third really critical metric that we should be thinking about. It's terrifying. None of us asked for it. Second meaningful content. This is the one we've been talking about. This is where the third parties come in, and then voila, the final page. We've seen sites that just add these scripts, and they go from like 4 seconds here to like 12 seconds. I mean, it's really devastating. So what can we do about it? Things we could recommend our clients to do are don't vary the content of the page for first-time visitors. And that's not going to happen. They want to do that. You could asynchronously load the scripts. Maybe don't change any content that's above the fold. They don't want to do that either. Definitely advocate it. It's the right thing to do. moving variation to the server side is a third thing. Ideally, we want to do that, right? And that kind of gets back to those tried and true progressive enhancement patterns. Do the heavy lifting on the server and give the user the end result right away. Server-side tools have been around a long time for A/B testing and personalization. Recently, though, we're seeing a lot of this move to the client. For one of our clients recently who was doing a lot of client-side testing, we wanted to do some experiments, sort of a proof of concept, where we moved the A/B testing to kind of a middle layer on Cloudflare. And middleware is not necessarily a new thing in itself, but their solution is pretty new. It uses service workers, like Jason was talking about, on the edge cache. So by running service workers at the edge, we can make transformations like this and then serve the end HTML right away. And it's kind of cool because JavaScript developers already know how to write service workers, so now they can be server-side workers, and that's also pretty dangerous, but it's enabling and cool. There's a cool playground to use on Cloudflare's site where you can run a worker over here on any page, well, most any page on the web, and see the modified results. So recently we did a couple scripts for this client to do some A/B testing. The first one is a sort of text swap. So it's for really simple A/B tests, like swapping a word. In this case, donuts for stroopwafels. And in this case, it would just be a simple find and replace, right? So donuts is in the markup to begin with, and then we have a worker that, this is really the whole thing, but you can pay attention to just the highlighted line, which does just a JavaScript replace, right? And that ends up sending to the browser the end response that we want in the HTML. It actually does a little more than that, too. It's going to carve up the users into two groups, set a cookie so they can track whether it's efficient. And I'm going to provide the URLs to these so you can check them out. But it's limited in scope, so find and replace only gets you so far. So we made a second one that did a little more work. It swaps big sections of HTML. And I made a unique design so that it was clear that there was more going on than just a word changing. And configuring this worker all takes place in the markup instead of the worker. So it's just the same script looking at any page on their site. And you can configure tests using HTML comments. It looks a little archaic, but it's pretty powerful for the team. They can name their test, my test, all the way down here, and then you've got the A group up top and the B group. And what the worker does is it just carves up those users into two groups and deletes the commented section that's inapplicable and just returns the markup. So we'll open source this on our blog soon. Here's a happy B group response. Stroopwafels, love those. And while I'm here, there's on the Cloudflare blog, there are other examples like that that you should check out. Once again, the URL will be in my deck. Generally, I'm not saying use these so much as try to move those tests to the server side. So another area, aside from third-party scripts, that I find that we're running into a different problem with page weight, particularly on home and landing pages. This occurs when the teams are really enabled with tools that they can live update the content on these often really heavy pages, like this one. Home pages where it's just, we design these modules with all sorts of configurations, and it's their job to fill it with lots of great content like this, and it works. This is what people expect when they come to the site. So, lots of images, video, carousels, containing images and videos and more carousels sometimes. One of the best things we can do that might have been mentioned a couple times in the conference is just make sure the images are responsive. We have two new standards that are really great for that, image source set and the picture tag. The first one, you just sort of offer up a series of sources to the browser and describe them and let the browser make the call. This one is more for art direction, so you can say at this breakpoint, do this, at this breakpoint, do that. So those are really great, and they have great fallbacks now. I wouldn't polyfill them anymore unless you really, really need that fallback to be a certain way. The fallbacks are really good now. Another thing we can do to help our clients along on these marketing pages is make it easier to get the markup right? Having a CMS drive the widgets like that is ideal. But we find that a lot of times marketing teams are either feeding raw markup into third-party A/B test little tools, or they're raw editing the homepage and the top of landing pages on the site. And that's an opportunity for us to really get the markup right, because it's tricky. Responsive image code is really tricky. So we've been building, let me let it play. There we go. We've been building little forms like these in Vue that are just really quick and easy, but it's so nice to not have to remember syntax like that. And you can imagine we make a lot more configuration available to them once we can make these forms drive the components in their pattern libraries. Another thing we can do to mitigate the weight on these pages is lazy loading, like Katie was mentioning. BBC is a good example of that. You saw Katie's example earlier, so I'll skip over it for time. But on the implementation side of it, I think it's kind of interesting. They use a script called Lazy Sources by Alexander Farkas. And it's basically the same markup you're familiar with, but you prefix each image attribute with data, so you're effectively breaking the image, right? And you would not want to use this technique for a critical portion of the page. But further down, it's really nice. As you scroll, the script evaluates whether or not an image is in the viewport, and it will change those attributes to source and source set and let the browser apply it. You might notice that lazy sizes doesn't really fit with my progressive enhancement narrative for the whole thing, and that's true. But the good news is that this is one of those areas that we don't have a good tool for yet, but it's finally maybe coming. This is an article by Ben Schwartz of Calibre, the monitoring tool, and he wrote a nice piece on this new Chrome feature that's currently implemented. It's under a flag, but you can turn it on and test it out, and it lets us use native lazy loading. I'll show you how it works. Couldn't be simpler. It's just lazy load equals on, and that'll let the browser decide whether or not to load an image, depending on if it's within a certain range of pixels from the viewport. And that is a decision that's sort of opaque, at least from what I could tell, but it's calculated, and it works really well. It's also for iframes, which could potentially have unexpected damage on a page, depending if you're relying on iframes for anything. So they're being careful in testing this and deploying it. But I'll go over the options real quick, because it looks like at least the images part is being treated pretty seriously in their specifications. So on is the value I showed you. And that means, yes, lazy load this image if you can, and it's out of the viewport. Off is, don't do it, obviously. Auto is letting the browser decide to do it. And interestingly, this is the same setting as not even having a lazy load attribute at all. So that really describes the intent of where this is going, right? Like, a lot of existing pages on the web are going to be able to adopt this pattern without us modifying the markup at all. So here's a quick demo with that feature enabled in Chrome. I made the first image not lazy, which should be obvious, with this woman and her 2 kids, not lazy at all. All the other images that come below it are lazy loaded once the page comes in. Here's the loading process. Now keep your eye over here. You can see 206s. And it's pretty cool. These 206 responses are actually giving just a little bit of information about the image, just enough for the aspect ratio, so we can fight the reflow while the image has not come in yet. That one's really lazy. And then as they scroll down the page, those 206s turn to 200s. So I think that's something we could use soon. It's pretty neat. To wrap up, I think our notion of what it means to break the web and break user experience is always shifting. It's shifted 3 or 4 times just in this little recap today. But we can take comfort in the idea that returning to these resilient progressive enhancement patterns is often the solution that we need. It can get us out of a jam. So I think as developers, we need to defend access to our services, right? But I think the need to play defense is becoming more of our role, right? We know how to optimize the first experience when we're making a site fast in the first place. I wouldn't say it's a solved problem, but our tooling is so good for that now. And I think this new frontier that's really a big mystery is how to keep a site fast with all the people who are able to make it not that way. So work on unbreaking things. I hope you found some useful examples today. This is my book, and you can find me on Twitter and all that, and at Filament Group. Thanks so much.
Thanks, Scott. Do you have time for a few questions?
I think I do.
Yeah, we've got a couple minutes. All right. I remember you tweeting about critical CSS, about, I think that, or a specific case study in the wins there, and other people have echoed that as well. Is there a cutoff point, though? Like, is there a certain size where critical CSS you think it's not worth inlining?
Yeah, well, I don't think I really have a hard number on that. It's interesting because you, traditionally when we were writing about these approaches, you would want to fit whatever you could into that initial 14 kilobyte window that Yoav was talking about. But we did do some testing where if the CSS was slightly larger than that, was it still worth inlining or pushing? Or should we just, like, scrap the idea? And we found that it was a lot faster to inline a slightly bigger CSS file than to go out and make a new request to the server. So I think, emphasize trying to get it smaller than 10, 8 kilobytes, but if it's not, then test it, because it's often faster.
And in your experience, you've probably done this with a lot of websites. Is that about where it hits, 8 to 10K? Usually you can get it down to that?
I mean, it will vary on the complexity of the design, right? So the more style that's going on in the page, and also how well the CSS is written, But I guess so. Yeah, 6, 7K is typical.
Can you talk about putting link rel style sheet tags in the head versus the body? Any difference there?
Yeah, so that's a new and I think really interesting thing. Jake Archibald has been talking about that quite a lot. And the idea is that you can block rendering beneath a link rel style sheet, just a traditional CSS link, if you put it in the page. So everything that comes before it will render, and then the parser will stop until it fetches that style sheet, then it'll continue rendering. It really caters well to a modular page approach. Personally, I can't see practical uses yet for the way we build sites. Like, I think you have to have a really modular, isolated approach to each module on the page for it to work that way. We have a lot of overlap across components in a page when it comes to theming and styling and all that kind of stuff. But I think it's fascinating. I mean, I hope it works. It's simpler, right? It's declarative. So.
I can see what you're saying, though, about the styles applying more broadly.
Yeah, it's tricky, but I look forward to reading more about, because the people charging ahead on it seem pretty convinced that it's a good pattern.
We've got more questions, but we got to take a break. You want to hang out here for a few minutes if people come up for questions?
Sure.
Yeah.